So let's take a look at this problem from 6b. It's a very difficult problem because they want the second derivative and it's implicit differentiation, which just means there's a lot of steps to take. So we need to take those steps and see if we can simplify in the way that the computer is looking for. All right, so if we look over here, what do we see? We need to take the derivative of this entire thing. So d over dx, 5y squared minus xy plus 3x squared equals d over dx of 4 in this version. Well, the derivative of any constant is 0, so we know it's just going to go to 0. That's kind of nice. Now remember, with implicit differentiation, that means y is a function of x. Okay, y is a function. So when we come to taking the derivative of y, we're going to do dy dx because it's a function of x. So here with the 5y squared, when we take the derivative, it's chain rule. So we're going to get 10y. 2 comes down, 2 times 5 is 10. So we get 10y. And then the derivative of the inside is dy dx by chain rule. Now, for that second term, we're going to have to do product rule. So the derivative of x is just 1. So we just get that y there. And then for the first part, we leave it alone. Second part, it's going to be dy dx. And then for the third term, which has a 3 there, just take the derivative normally. 3 times 2 is 6. All equals 0. Okay, getting closer to the first derivative. So dy dx, dy dx. I need to put these together. So I'm going to try to solve for dy dx. So that's 10y dy dx minus x dy dx. I'm going to send everybody else to the right-hand side because I don't need them right now. All right, now let's factor out dy dx. Okay. Now I've solved for I've got dy dx isolated. I can divide both sides by what's in the parentheses, and that gives me dy dx equals y minus 6x over 10y minus x. That's the first derivative. Okay? That's what we needed just to get going on this problem. They want the second derivative. Okay. So that means I have to take the derivative of this. Let me get rid of all this so I have some room. Okay. So we need to take the derivative of what we just found. All right. So for here, we're going to have to recall quotient, right? So that means d squared y over dx squared. Second derivative, we need to do quotient rule. So derivative of the numerator, well, what's that going to be? That is dy dx minus 6, okay, times the bottom minus, leave the first part alone, take the derivative of the bottom part, so that's going to be 10 dy dx minus 1. And then the denominator will get squared by quotient rule. There we have it. Okay, it's looking like a mess. It's going to get even messier. Now we need to distribute and cancel any terms or combine any terms if we possibly can. So let's do that. Okay, so dy dx times 10 would be 10y dy dx minus x dy dx minus 60y plus 6x. I think I got that part right. Now we got to watch our minus sign, and since I don't want to do a sign error at this point, I'm going to do a bracket. So I'll distribute, so we get 10y dy dx minus y minus 60x dy dx plus 6x. And that's still over the same denominator. What terms can we cancel? What terms can we cancel? So we have 10y dy dx, 10y dy dx. Those can drop off. What else can we have? Looks like we have 6x. That goes away. I see things that are similar, but I don't think anything else drops off. So I'm going to go down another line. So I have negative x dy dx minus 60y. And then remember, this is minus minus, so that's going to be plus y. And then minus minus, so plus 60x dy dx. So, okay, anything else we can combine? So yeah, looks like here we have negative 60y plus y. So that'd be negative 59. And then we also have negative x dy dx plus 60x dy dx. So that becomes 59x dy dx minus 59y 10y minus x squared. Okay. Getting closer. What should we do next? Okay, so here's the issue. In our answer of the second derivative, we have the first derivative. So what I'm talking about is right here. So we still have dy dx in the answer. And that's fine, but what we really need to do is we need to plug this in for the first derivative. I'm going to change color since we're doing kind of a big step here. So this is the same as 59x y minus 6x on 10y minus x minus 59y over 10y minus x squared. Okay, now I have at least an answer that only has to do with the variables. I don't have a derivative in my answer. Well, how are we going to fix this, right? Like, now we have this fraction we have to deal with. It's getting pretty ugly here. So what can we do? Well, from there, we could, I noticed that this is the same as this. Okay, so I can use that to my advantage as far as algebra goes. So I think what we could do is we could multiply this by 10y minus x, 10y minus x. And then we'd have something we can kind of work with. So if we do that, then we have 59x, y minus 6x, minus 59y, 10y minus x, all upon 10y minus x cubed. Since those were all the same, I can just cube it. All right, now I can distribute and simplify. And it's getting kind of ugly, but that's the name of the game, I suppose. So we have 59xy minus 354x squared minus 590y squared plus 59xy upon 10y minus x cubed. Now, what can we combine? What can we cancel? It looks like we can just rewrite that. So we can just factor out a term. So we have 59, 354, 509. So we can factor out the 59. That's pretty easy. And then from there, 354 divided by 59, 6, 10, x. Yeah. So then from there, yeah. Okay. All right. Hopefully that helps. But I think this will also be evaluated the same. Okay. Let me know if you have any further questions.